So welcome as I run you through some multiple choice. Again, this is the 2024 GCE question paper. So we want to go through some multiple choice and see how you needed to go about it, which ones are the best options. So A1 says the diagram shows a simple pendulum that swings from A to C and back to B in 0.75 seconds. So from A to C and back to B, the number of oscillation is that's 3/4, and the time that is taken is 0.75 seconds. Then it says what is the period of oscillation. So remember, period is time divided by the number of oscillations. So the time is 0.75 divided by 3/4. Be careful as you put that on your calculator. Calculator can make you pass, even failing, if you don't know how to use it properly. So that is going to give me 1, so I can just say 1.0 seconds. So the best option was simply C there. A person fell from a transmitter of height 8 meters. Ignoring air resistance, calculate the time taken for the person to hit the ground. So since he was falling for a transmitter and the height of the transmitter was 8 meters, we can apply the formula S is equal to UT plus 1/2 gravity then time squared. But this S is representing the height. But because it started, obviously there should have been, the initial is 0, so this will cancel. My formula will reduce to half GTH. So the height was 80, which is equal to 1/2. Gravity is simply 10, then time squared. 2 there, 1, 2 there, 5. So if you notice there, it is going to give us 80 is equal to 5t squared. Then I can divide 5, I can do it the other side. So t squared would be equal to, if you divide 80 divided by 5, that's 80 divided by 5, it is giving me 16. Then you can introduce the square root, then t is equal to 4 seconds. Remember, it can be plus or minus, but plus or minus time cannot be negative, so we take the positive part, and you can see A was the best option there. An astronaut can jump from a greater vertical distance on the moon than on the earth. This is because the gravitational field strength is so the gravitational field strength on the moon is less. Because it is less, you can actually jump as high as possible than on earth. Where gravity is greater, it will be pushing you down. Then A4 says a 100 centimeter uniform beam is balanced when pivoted at X. So remember, this is a 100 centimeter uniform beam. A mass of 200 rests on the beam as shown in the diagram. Of course, it was not placed properly. Remember, the weight or the mass acts right at the center. But anyway, it's okay. What is the mass of the beam? So the mass of the beam will act right at the center. So from here to there, 20 plus 20 is 40. So at 50, I should have a 10 somewhere here. That's where the mass will be acting. So somewhere here, it will be, there will be a 10 centimeter. So using the principles of moment, this mass times the distance from the pivot to where it is, which is 10 centimeters, will be equal to that mass, which is 200 grams, times the distance from the pivot to where the 200 is, which is actually 20 centimeters. So I'll divide 10 centimeters. I'll also do it the other side. The centimeter will cancel. 10 there, 1, 10 there, 2. 2 times 200 will give us 400 kilograms. So you can see the answer was right there. Hopefully we are together and we're able to see how to go about it. It says which types of surfaces are best absorbers and best emitters of infrared radiation. Basically, those that are black and dull are both good emitters and best absorbers of heat. So if you look at the options there, A was actually the best option there. The following diagram shows a sealed gas syringe containing a fixed mass of gas. The piston is moved from position 6 to position 3. The temperature of the gas does not change, so it doesn't change. So it is moved from 6, then they push it to 3. Now, according to Boyle's law, pressure is inversely to the volume. When you reduce the volume, you make it small, you're increasing the pressure. What happens to the pressure of the gas when the piston is moved as stated? So you have seen the volume has been reduced to half. So when you reduce the volume to half, it simply means you are doubling the pressure. So the pressure of the gas becomes what? It actually becomes double. That's the idea. Then a drum of water of mass 200 kg is rolled up a plank of length 4 centimeters into a platform 4 meters high, and take gravity to be that. What is the mechanical advantage and the work done on the drum against gravity? So remember, the work done against gravity is equal to the potential energy, mass gravity times height. So the mass is 200, gravity 10, and the height, which is simply 2. So if you look and multiply that, that will give us 4,000 joule. So that is simply the work done. Now they have not given us much information to calculate the mechanical advantage, because mechanical advantage is load divided by effort. Yes, the load will somehow be a 2,000 newtons, but we don't know how much effort that was. But we can assume this system was actually ideal, where the velocity ratio is equal to the mechanical advantage. Slightly, let's make that assumption. We know that velocity ratio is equal to the length divided by the height. So the length is 4 divided by the height, which is 2. So that will give me a velocity ratio of 2. But of course, if this is only possible when the mechanical and the velocity ratio will be equal, when this system was ideal. But if it is not ideal, then the mechanical advantage should be less than the velocity ratio. At least we have an idea. So if you look at, there are two options. Now you cannot have something that is actually too much less than that which is 0.5. So that one would actually be the best option here. All right. 8 says a radio station emits radio waves at a frequency of 60 megahertz. What is the wavelength of the waves? Now the frequency is simply 60 megahertz. You need to convert this by multiplying 60 multiplied by 10 raised to the power 6, and that will give us now in hertz, because remember 1 megahertz is equal to 10 raised to the power 6 hertz. So we have just converted megahertz to hertz by multiplying by that. So since the question says the wavelength is equal to speed divided by frequency. Where are we getting that? It's from this formula here. So the speed for all these radio waves are electromagnetic waves. They travel at the same speed of 3 times 10 raised to the power 8 divided by 60 multiplied by 10 raised to the power 6. So if you work out this one, that would be 2, that is 7, that's 1, and that will give us a 5. But anyway, 3 exponent 8 divided by 60 exponent 6, what is that going to give us? Yes, it is actually giving us a 5 meters. So that was the correct option there. The following diagram shows a water wave generated by a stone thrown in a pool of water. What is the value of the period and the frequency? So remember, this is the displacement time graph. Frequency is the time taken to make one complete. So what's the time taken to make one? It's on here because this is time in seconds. So the period is simply 20 seconds. And what is the frequency? We can apply frequency is equal to 1 over period. So it will be 1 over 20. And when you divide 1 over 20, it will be 0.05. Believe that 1 divided by 20, that will give us 0.05. So this is in hertz. So you can see the correct option is that one there. I hope it is actually helping you as you revise for your exams, or if you're just revising. 10. A ray of light enters a block of glass from air and emerges at an angle of 25. What is the angle of incidence of the ray if the refractive index is 1.5? So the refractive index 1.5. Now it emerges at an angle, that's the angle of refraction, which is 25 degrees. So they want us to find the angle of incidence, which we don't know. Now we can apply Snell's law. Refractive index is equal to sine I over sine R. So we just want to make that one the subject of the formula. So you can say over 1, so it will be sine I is equal to the refractive index times sine R. That's what we mean. So it will be sine I will be equal to the refractive index 1.5 multiply, in this case, so the question, what is the angle of incidence? So sine